Hello everybody, my name is Sahar Karufa and I'm going to give you a lecture on active thermal sustainable design. Now, active thermal sustainable design is actually about air conditioning, which we prefer to call climate control, and sometimes in the trade it might be called HVAC. Now, HVAC is a synonym for heating, ventilation, and air conditioning, and you might read it in the books and tutorials and elsewhere, so you should know what it means. But why are we studying this subject? Several factors are important to us as architects. First of all, it heavily affects our design, and I will show you some samples in a few moments. It also affects the building users considerably. You don't want to live in a building which is too cold or too hot. You want to feel comfortable where you're living or working. It also might use a lot of the building capital. That might rise up to 30% in some special kinds of buildings, special hospitals, special pharmaceuticals or research establishments, but that is rare. Generally, it's between 7 and 5%. More important, air conditioning actually uses 60 to 80% of the country's electricity production over here in the Middle East and the Gulf. In countries like ours in the UAE, we use a lot of air conditioning for cooling our houses and homes and working places, and that is a lot. Our CO2 footprint is one of the highest in the world, and that responsibility of reducing this number, that falls on us as architects, and we can do it, and I will show you how to do that later on in the course. This is one sample of how I told you that air conditioning might affect your design. This is a failed case, but even when the air conditioning is working okay, it still might look really ugly. There are no failures over here, but this building definitely does not look okay. Again, it's not just the dishes, but also look at all the air conditioners over here. They're not exactly good looking. And this case is even worse. This is not in the UAE, this is in Asia. This is a better sample. It's not great, but you don't see the air conditioning actually ruining the facade. They've put them behind balconies and put some patterns, steel patterns in front of them, steel grills. And it's okay, the air conditioning is not doing anything bad over here. And here they are, behind the grills and the balconies, barely visible from the outside. This is something which falls on us as well as architects. This is a shaft. Now, this is a service shaft, and we put the air conditioning ducts and piping and sewage and water supply in these shafts, but we use them in a way that they allow for maintenance. Somebody should be able to go up and down the shaft to do maintenance, and this is a bad sample. It's overcrowded. They should have used a bigger shaft. So what is the objective of an HVAC system or a climate control system or air conditioning? Well, the first thing that comes to mind is lowering the temperature, giving us the temperature that we want. But that isn't exactly the whole picture. What we want to achieve is actually thermal comfort. And it's not the same as temperature, and I'll explain that in some detail as we go along. We also want a healthy environment in the inside, and air conditioning can help us do that. It can supply fresh air in most cases. It can filter out the dust and particles, maybe even those that cause allergies if necessary. But it also can help us achieve a good design, can help us achieve green buildings in a subject which we call sustainability, so that we can reduce the CO2 footprint and reduce the amount of energy that we are using for air conditioning. So thermal comfort, which like I said is the objective of air conditioning, it's the expression of satisfaction with the thermal environment, which means you want to feel thermally comfortable. The temperature might be a little bit higher, it might be a little bit lower, but you want to feel thermally comfortable within that temperature. Now, you might feel comfortable at 27 degrees centigrade. You might feel hot at 27 centigrade. You might feel cold at that temperature as well. All those are issues related to thermal comfort. You might feel colder at a higher temperature in certain circumstances and hotter in lower temperatures under different circumstances. I'll tell you what those circumstances are in a few moments. But how generally, let's start with how a body regulates its temperature. If you're in a snowy blizzard outside, how does your body keep you cold? And if you're in a hot environment, how does the body keep you reasonably hot? How does the body keep you hot in a cold environment and cold in a hot environment? So in a cold environment, what does the body do to compensate? You shiver. It means your muscles contract and expand rapidly, producing energy. The food you ate, it turns it into heat, and that will heat up your body a little bit. It saves you from being cold. But what happens in a hot environment? In a hot environment, your body will sweat. It will produce sweat. It will run down your body and evaporate. The evaporation will produce cooling. And that is, I'm going to explain it to you in some detail in a few moments. It's part of the thermal comfort items. And these are the 7 items that affect thermal comfort. Starting with air temperature, which is probably the most important. Now this is the thermometer. And you can see right now it's 37 degrees centigrade. Generally, that is hot. We feel comfortable at around 24 degrees centigrade, everything else being equal. But we might feel cold or hot during those temperatures. But if you're sitting around not doing much of anything, most people, by most I mean 95% of them, will feel reasonably comfortable at 24 degrees centigrade. But if you have a lot of humidity in the room, or in the air, you're actually going to feel hotter. Now the reason is humidity or excessive humidity will affect evaporation of the sweat on your body, which we said affects how your body cools. So if that system does not work so well, you're not going to feel so comfortable. How does the whole system work? Well, this is some water, and these are the yellow circles are water particles, molecules, and they escape from the liquid over here onto the air, changing phase from liquid into gas. That phase change requires energy. So it will absorb energy from the surroundings in order to turn into gas. And it actually needs quite a bit of energy, 500 and something calories for each gram of water, which is quite a lot if you consider that you actually eat around 1,000 calories for a big dinner. So half of that to evaporate 1 gram or 1 centimeter cube of water is quite a bit. This is a very efficient system. But what does this have to do with humidity? Well, right now there's a limited number of air molecules in the air, which is what happens when the humidity is relatively dry. When it becomes humid, more molecules of water will exist in the air. That is the humidity. And these molecules of air will compete with the molecules in the water which want to escape, leaving them less room. So evaporation will go down and the cooling process will be less efficient. So more humidity means you feel hotter. Less humidity means you feel colder because evaporation of sweat will be faster and more efficient. Now we have the opposite effect when it comes to air velocity. Air velocity also affects how well we feel. If you go outside in a gentle breeze, you will feel cooler. And the reason is, same thing, evaporation. If there is some breeze in the air, it will take the molecules away from the water surface or the sweat surface, allowing the new molecules to evaporate from your body, from the sweat on your body, increasing evaporation and making you feel colder. Now you need to remember that your body always sweats. Even in 0 and freezing temperature, your body will always sweat. So no matter what the temperature outside is, a little breeze will make you feel colder by evaporating more sweat. The other factor, fourth factor, that makes us feel hotter is radiation. More radiation from the sun or anything else will make us feel hotter. That's not difficult to understand. If you're standing outside in the shade in the sun and you're feeling hot, you walk over to the shade and you immediately feel colder because there's less sun radiation on you. Any kind of radiation will make you feel hotter. Then we have the metabolic rate, which is how much activity you're actually doing. Now, if you're sitting and you're comfortable, your metabolic rate is low. You don't need a lower temperature. You're already feeling comfortable. But if you run around, you're jogging, you're working, and if you stay jogging and running for about 10 minutes, you're going to start feeling hotter. That is an increased metabolic rate. The higher metabolic rate, the hotter you feel. So you're going to need a lower temperature to feel comfortable. And metabolic rate is a bit difficult to measure because there's no units, but we need some kind of indicators, numerical indicators. So this is an empirical schedule which gives us some indication. So if you're reclining and you're not doing much of anything, your metabolic rate will be 0.8. But if you're standing and doing some light activity like I am right now, I'm delivering a lecture, my metabolic rate will be double yours at reclining. It will be 1.6. But these have no units. They're just empirical indicators. The penultimate factor that we're going to discuss today is clothing insulation. So in hot weather, we use less clothing. It'll make us feel colder. But in cold weather, we're going to add clothing so that it would insulate our body heat from the cold outside. So more clothes, we feel hotter. Less clothes, we feel colder. Now the final factor, and I find students remember this more than anything else, although it has the least effect, which are personal factors. Now normally, if you put 9 people in a room and you put the temperature at a certain setting which feels comfortable, 9 of them will say yes, we feel comfortable. You might find one that says no, I want it a little bit colder or a little bit hotter. But generally most people in normal humidity and a slight air movement and slight breeze will feel comfortable at around 24 degrees centigrade. But that might be affected if the person is sick, or there are certain psychological effects which might make him feel less cold or less hot. Thank you very much for listening to this lecture. You can use it for a quick review and things like that.